Alright, this is section 3.1, solving a system of linear equations by graphing. So that's kind of a complicated title. But first, what is a system of linear equations? So you already know what a linear equation is. It's the equation of a line. So like these two up here, they're both equations of lines. So they're linear equations. And what makes them a system is there's two of them. So it's a system of linear equations. And there's lots of different ways you can solve the two system of linear equations. But the first is by graphing, and so that's what we're going to talk about right now. So how do you know when something is a solution of an equation? So if I graph the equation y equals x, I would get a line that looks something like this, but straight. And so I know this point on the line is a solution of the line. This point on the line is a solution of the line. Any point that's on this graph that's on the line is a solution of the line. But this point out here, that's not a solution. So if the point is like way out here on the left or somewhere that's not on the line, it's not a solution of the line. And so what they want you to do in these two equations that they've given you is find the solution of those two. So the solution of two lines is actually represented by the place where the two lines intersect. So for example, if these two lines are graphed and they intersect here, this point right here, that would be the solution of that line. And so that's what they really want you to do in questions when they ask you to find the solution by graphing. They just want you to graph both of the lines and then find the point where they intersect, and that's what the solution is. So we're going to do that right now. The first equation says 4x plus y is equal to 8. Now there's something wrong here. The first thing that's wrong here is this is not in the format I'm used to. The format I'm used to when I'm graphing is y is equal to mx plus b, right? Because then I know what b is and I know what the slope is and I can graph that. But this is in the standard form. It's in this form, a different form that I'm not used to. So what I'm going to do first is I'm going to get it in the form y equals mx plus b. And to do that, first you isolate the y. So here it's 4x plus y is equal to 8. And I'm going to isolate the y. So to isolate the y, I'm just going to subtract 4x from both sides. So right here, do minus 4x to get rid of it from here. Minus 4x on the other side. And then you basically get y is equal to 8 minus 4x. This is almost mx plus b. I'm going to rearrange these two terms right here to get y is equal to negative 4x plus 8. And now this is the kind of function that I recognize and I know how to graph. Because I know b is equal to 8, that's the b. I know m is equal to 4, or negative 4, that's the slope. So let's come up to the graph here and do b equals 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. It's actually up here. I'm going to graph it right here. That's the point 0, 8. And then we know m is negative 4, so I'm going to go down 4, 1, 2, 3, 4, and then over 1. And I'll do that again, 1, 2, 3, 4, over 1. And then you can kind of see that there's a line forming, 1, 2, 3, 4, over 1. Then you can see that there's this line that's forming right here. And then I'm just going to connect the dots. And that's it. That's the first line. It's the first line right here. We'll make it a little darker so that it's easier to see. And that's it. There's the first line we've graphed. And now we have to do the same thing to the second line. So the second equation reads 2x minus 3y equals 18. And so we have the same exact problem we had before, which is this is not in the format y equals mx plus b, and so that makes it hard to graph. So let's just get it in the right format. 2x minus 3y equals 18. So I'm going to come down here and write that. 2x minus 3y is equal to 18. And I want to get this in the format y equals mx plus b. So first I'm going to subtract the 2x from both sides to get rid of it, minus 2x. And that's going to be negative 3y is equal to 18 minus 2x. I'm going to rearrange these terms to get it in like the mx plus b format. And so that gives me negative 3y is equal to negative 2x plus 18. Now, to get the y alone, I want to get rid of this negative 3 that's on the y. So I'm going to divide this negative 3 out from this side, and then I have to divide it out from this side too. So each of these get divided by a negative 3. And so the final equation is y is equal to positive 2/3, right? Because dividing a negative by a negative gives you a positive. So positive 2/3 x minus 6. 6 times 3 is 18. This is getting divided by a negative 3 right here. So now I have my equation. We know b is negative 6, so this is b. We know m is 2/3, that's m. And now we can just graph it. So if we go up to the graph, go to b is negative 6, 1, 2, 3, 4, 5, 6 down here. The slope is 2/3. That's 2 over 3. That's rise over run. So you go up 2, rise, 1, 2. To the right 3, run, 1, 2, 3. And then you put it right here. And then I can go up 2 again. And then 1, 2, 3 to the right. And I see this line forming. And I'm just going to draw the line through those points. And just very quickly going to make that line a little thicker so that it's easy to see. And then there you have it. Those are the two lines. You can see on this graph that they intersect right here at this point. It's not super clear, but you can see if they were both drawn very straight, they intersect right at this point right here. And that point where they intersect, if you count, is 1, 2, 3. So x is 3. And the y is 1, 2, 3, 4. Y is negative 4. So the solution to these functions is 3, negative 4. That's the solution. That's the point they intersect. So now you don't have to guess that you did it correctly. You can actually go back and check your answer. And so how do you check your answer? Well, it's very easy. I'll show you how right now. So what you can actually do is you can take that point that you found, 3, negative 4, and plug it into each of the equations. And it should work on both equations. If it doesn't work on both equations, you know you did it wrong. But if it does work on both equations, you know you did it right. So for example, let's plug these numbers into the two equations. We're going to do that right now. So the first equation says 4x plus y, which we'll put as a parentheses, is equal to 8. And so what is x? X is 3. We'll plug in 3. What is y? Y is negative 4. We'll plug in negative 4. And so the first equation says 4 times 3 minus 4 should equal 8. And is that right? Yes, it's right. That means it fits into the first equation. Now, you also have to check the second equation to make sure it fits there too. Second equation says 2 times x minus 3 times y is actually equal to 18. So you plug in the same things. So x right here is 3. Y right here is negative 4. So this is saying 6 plus 12 should equal 18. Is that true? Yes, that's true. That shows you that this point is a solution of both of those equations, which means you did it correctly. But in this method, you found it by graphing it and then visually telling the point where they intersect. Next, we're going to talk about a different method of solving equations.